So in the previous video we talked about homogeneous equilibrium. Now we want to talk about heterogeneous equilibrium, which is going to be where species are in different phases. And so if we look at an example equilibrium, this would be a heterogeneous equilibrium. We have calcium carbonate in equilibrium with calcium oxide and carbon dioxide. So we have two things that are in the solid phase, one thing in our gas phase. So go ahead and write your equilibrium constant expression for this equilibrium. Go ahead and pause the video. All right. So we have K, our equilibrium constant, right? And we're going to write this in terms of concentration. So we have Kc. We want to have our products over our reactants. But remember, equilibrium is where our rate of reaction is the same, so we're basing it on concentrations. So our equilibrium constant expression for this reaction is just the concentration of carbon dioxide. Now, for those of you who are screaming at your computer right now, we still do have another reactant here, calcium oxide, which is a solid, and we have calcium carbonate as a solid. Now, if we were to write our equilibrium constant expression, if you wanted to write it this way, we would need concentration of a solid. Okay, we would need concentrations of this solid, and we would need concentrations of this solid, right? So we need moles per liter. Concentrations of solids and also liquids doesn't make sense. Okay, we don't have this changing ratio of moles per liter. We can't make a solid more concentrated. We can't dilute a solid down. Same thing for liquid. We can't make a liquid more concentrated. We can't make a liquid more dilute, okay, as long as it's a pure liquid. Solutions are different stories. Something that's in the aqueous phase, well, we have something dissolved in water, so we can add more of what we dissolved to increase that concentration. Or we can add more water to make it more dilute, to change its concentration. But solids and liquids, pure solids and liquids, don't have a concentration. Okay, we can't change their concentration. If you want to convince yourself of that, or if you want to argue with me, what I'd like you to do is take a glass of water, stick it in front of you, and make that glass of water more concentrated, and make that glass of water less concentrated. So something to think about there. So essentially, that is not correct. Liquids and solids are not included in equilibrium constant expressions because they do not have a changing concentration. So you can either think of this as The liquids and solids either don't change their concentration or they don't have a concentration at all. Okay? Either way, it gets you to the same conclusion. Now, because our carbon dioxide here is in the gas phase, we could also write a Kp expression, which looks very similar because it's just based on the concentration of carbon dioxide, not the concentration. Nope. Sorry about that. Partial pressure of carbon dioxide.